Hey, welcome back to Mr. P. with Algebra 2. This is Unit 1, Topic 3, SLT23. Starting off with a warm-up with logarithmic functions, which we just learned in the last video. So that's common log, so that's 10 to the power of what equals 1,000, and that would be 3, 10 to the third power. If I change this from logarithmic into exponential format, so that would be 4 to the what power? I can make that x equals 64. That would be third power. Natural log, so meaning e to the power of 1 is e. This is what base with the exponent of -2 is equal to 1/4. So that would be 2, because 2 to the second is 4, but it's 1/4 because it's a negative exponent. 3 to the what power is 1/9, and that would be -2, because 3 squared is 9, and it's flipped because it's a negative. We've got 7 to the what power is 343. So 7 times 7 is 49, times 7 again is 343, so that's going to be 3. So 7 to the third power. All right, so in this lesson, we are going to be talking about exponentials and their inverses. So 2 to the power of x, 2 to the power of 0 is 1, 2 to the first power is 2, 2 to the third power is 4, then 8, and so forth. And if I went the other way, it's going to have an asymptote of 0. So y equals 0 to be exact. That's the asymptote. It's never going to reach that 0 line, so it's never going to have an x-intercept. The inverse of that would be log base 2 of x. And so it's going to be a perfect reflection over this y equals x line. So it's going to look something like this. And keep in mind, it's going to have a y. It's never going to have a y-intercept, meaning it has an asymptote of x equals 0, since it's a logarithmic function. All right, this is decay. So 1/2 to the power of x looks like this. And it's going to be the same thing reversed over this y equals x. So that's going to look like that, give or take. Okay, so that has an x equals 0 asymptote, and that would be log base 1/2 of x. Okay, now keep in mind that you can't put this in the graphic calculator, because the graphic calculator will only graph in base 10. So if you want to do that, you have to change it to base 10, and the way to do that would be log of x divided by log of 1/2. So if you do that, then you can put it in the graphic calculator, and that will graph this for you. But it has to be in base 10 because that's the way everything works. All right, so this one's already been done. So 10 to the power of x is like this, log base 10 of x. Remember, this is what power of 10. This is 10 to the power of. This is what power of 10 is that number. All right, so it's basically generally the exact same thing as I had already mentioned. So that warm-up, we can skip that. So this is the exact same one we had already done. This might actually even be the homework. So here it is. First, 10 to the first power is 10, so it's going to really slope up really, really fast, kind of like that. Its asymptote is y equals 0, and its domain is going to be all real numbers, and its range is going to be everything above 0. It's increasing the entire time, and it's never decreasing. Now, these two are inverses, as we had talked about before. This is 10 to the power of x. This is log base 10 of x. That makes these two inverses of each other. So if you want to plot this one over here, all you have to do is switch the points. 0, 1 becomes 1, 0. 1, 10 becomes 10, 1, and so forth. Okay, so it's going to look... Oh, whoop. Try that again. It's going to go like that. Okay, poorly executed, but you get the right idea. So this has an asymptote of x equals 0. It's never going to have a y-intercept. The domain is going to be everything to the right of 0, because as you can see right here, so I know I put my hand around the line, but you can't see that. So if I put my hand straight up and down right here, everything is to the right of that 0. There is no x of -1. It has no answer right here. Range is everything, all real numbers. Now, it should not shock you, but the domain and range, because these just got switched. Well, I already told you they're inverses of each other. That always happens in inverses. The domains and ranges will always be switched. And then here is the exact same thing, only it's been reflected over the x-axis. So 1, 0 stays 1, 0, but this 10, 1 reflects, it used to be here, is going to go to the other side. So it's actually going to look like this. Alright. Same thing goes for all of these. They're the exact same thing, only it's going to go up a little bit slower because it's got a smaller base. And then this thing's going to do the exact same thing. It's going to go something like this. And then this one's going to flip over the x-axis. It's going to look something like this. And this has, still has an asymptote of x equals 0, y equals 0. Same thing goes when it's power of e. Now keep in mind that e is about 2.718. So it should not shock you. Anything to the 0 power is 1, and e to the first power is about 2.7. So it should not shock you. That's going to look a little bit like that. It's going to increase a little bit faster than as if it had a base of 2. And then this one's going to look like this. It's going to be the exact same thing. And then this one's going to look like this because you're going to reflect it over the x-axis. Alright, so another homework here, and this may or may not be the same homework that you had. So the asymptote here would be x equals 0. The domain would be everything to the right of -1, so x can be anything greater than -1. Its range can be everything because it's going up and down infinitely. Now, I know that this is a logarithmic function because it has a vertical asymptote. It's always increasing, so anytime it's greater than -1, it's never decreasing. This one has an asymptote of 0. Everything else pretty much is the exact same answers. Domain, still everything greater than 0. Okay, so 0 is the domain. Range is all real numbers. This one has an asymptote, so it looks like it also has an asymptote of x equals 0, so it's decreasing like this. Range is up or down infinitely. Domain is everything greater to 0. X is greater than 0, and it's decreasing instead of increasing. This one looks like you've got an asymptote of 2. That's x equals 2. Remember, this is still a logarithmic function. Does not have a y, doesn't have a horizontal asymptote. It has a vertical asymptote. And I think that's going to be it. Oh, there's even more questions. Wow, there's lots of these. Okay. Are they the same thing? Oh. Pretty much the same thing. So these are still vertical asymptotes, so these are all logarithmic functions. Asymptote of x equals 0, x equals -3, this one's x equals 0, this one's x equals +3 is the asymptote. The ranges for all 4 of these are all, they're all real numbers, the ranges, but the domains are a little bit different because they all, like this one starts at 3, so it's everything to the right of 3. This one's everything to the right of 0. This is everything to the right of -3. And look what we have here, still the exact same kind of questions, all logarithmic functions. That has an asymptote of +3. This is an asymptote of -5, asymptote of +1, asymptote of -4. Same thing pretty much applies here. So they all have a range of all real numbers, and then you just look at the asymptote to determine what the domain is. Alright, I think I'm going to stop right there. Please give it a like if it helped you learn anything about logarithmic functions and graphing them, because that's what we did in this video. And please subscribe if you haven't done so already. Thanks again for watching. Have a wonderful day.